Hi, everybody. Maybe give people maybe a minute or so to get logged in. But we'll get started in just a second. Hope everyone's doing okay on this Tuesday. Okay, 4 p.m. Ready to do some science. Okay, today we're going to be making a pH indicator out of red cabbage. So red cabbage is really purple, but it's called red cabbage in the store. It just depends on what light it's in. So this has a substance in it that will change colors depending on the pH of the environment it's in. So I'm going to show you how you can make this today. And then we are going to test some common household substances to see what pH they are at, or at least if they are acidic or basic. Okay. So before we get started with doing this, I wanted to talk a little bit about the pH scale. So the P and the H actually stands for hydrogen. So something called acids and bases are two different types of chemicals. You might have seen acid-base reactions before. We do these things called neutralizations, where we combine an acid and a base. And a lot of the times those can create, they always create water. But sometimes they'll create other things like bubbles. So the baking soda and vinegar reaction that a lot of you have probably seen before, that is a neutralization reaction. But some other things are on different ranges of the scale. And so indicators usually will change colors based upon where they're at. So we are going to test these, and then I will also be using universal indicator or pH strips to tell us about what pH range they're in. And we'll kind of see how that compares to the cabbage juice as well. But the pH scale, 7 is neutral. And then things that are lower than 7 on the scale are acidic, and things that are higher than 7 on the scale are considered basic. Basic. Okay, so that's just a little bit of an intro. I see somebody in the chat saying that they can't stay right now and they can't watch it live. That's perfectly fine. These will always be posted on my YouTube channel, Sully Teaches Science, and you can go watch anytime after we record them. Don't forget to like and subscribe. I know that's cheesy, but we're making our way up in followers or subscribers. So tell all your friends, like, subscribe, turn on your notifications so you don't forget to tune in at 4 p.m. But we're going to go ahead and get started with our video for today. I'll take the red cabbage and show you how you can go about making your indicator solution. So you want to first start with probably cutting your cabbage into smaller pieces. It's pretty cheap at the store. And then you can cut it into maybe a more manageable chunk. Now, there's really 2 ways that you can go about doing this. One of them is if you have a blender, it's really easy to just shake the big chunks of cabbage and then put them in a blender. I don't have a blender, and so you can do 2 other things if you don't have that. One of them is you can just take the whole leaves and put them in the water, but you're going to need more cabbage if you do that. Another way that you can do it is take it with a knife and then cut it up in smaller pieces. Or if you have a grater, like a cheese grater, that works really well. So that's actually what I did when I made a lot of my pieces. So I just took a grater and I took the whole big piece of cabbage and I did like that. And it turns it into really, really small pieces. And then you can put that in your water. Now you want to put it in the water on the stove. If you have a blender, you don't actually have to do this step quite as much. A lot of the time you can get plenty of the colored pigment just by blending it, and you can skip the step of heating it. But what I did is I put all of my small pieces in a little bit bigger pot than this, but I boiled them on the stove for about 10 minutes. And then once you have all of those pieces, you can take that boiled liquid and then you want to run it through some sort of filter. So I just have my coffee filter here that I used. And then I took that and we just pour all of that and the pieces of cabbage into our coffee filter. And I just let that strain out, okay? And so I did that with a lot more water and cabbage than I just did there, but I probably used like maybe a quarter of the cabbage for about this much of liquid. So that's like 3, 4 cups. You can use as much of it as you want. What you're looking for is that whatever liquid that you get out of it, you get a dark enough color to be able to kind of work on our different, you want it to be like dark enough to change colors and still be able to see through it well. So you should get this really vivid purple color out of it when you go about making everything. Now, there was one thing that I forgot to tell you a little bit before, is the water that I put into this pot was not just water out of the faucet. You want to make sure you use what's called distilled water. And distilled water is exactly at that neutral pH of 7. It is just water. Distillation is a process where you boil something and then you capture the liquid. Once it's boiled, it will recondense and then you can capture that. So distillation allows you to purify that water and then you're left with just water. Where tap water, you're going to get some impurities. And depending on where you live, what type of tap water, could slightly differ in the pH scale. So I would recommend using distilled water. Not expensive at all. Distilled water, this was like 80 cents at Kroger when I bought it. So a whole gallon of it is 80 cents. It's not expensive at all. So I've got my indicator solution, and I actually diluted this a little bit. Once I collected mine from my filter, I added a little bit more water, and it was still a bright enough color. So we went ahead and used that. And then now we're going to go and test some of our substances. I'm going to set all this stuff off to the side so I have a little bit more room. Don't necessarily need that in frame anymore. I'll keep that there just in case we need a little bit more of it. I'll keep my distilled water there in case we need more of it. And then I'm going to move this a little bit to the center. Okay. And I'm going to zoom in my camera just a little bit. There we go. Okay. Take a look at some of the comments and see if I can answer any of your guys' questions in the meantime. Got some discussion of someone leaving to go take a shower. Really on task, guys. I'm so proud of you. Cabbage juice. I will tell you, it doesn't smell quite so bad before, but about 2 hours ago, my kitchen smelled really, really terrible. Just like straight, like gross cabbage smell. And not like normal cabbage smell, because generally I like cabbage a lot. Coleslaw, love it. But boiled cabbage, not so great. Unfortunately, there's not going to be any explosions today. Good question. It was kind of cold outside, so I decided that I wanted to do an indoor demo today. But I'm going to try to get the stuff to do elephant toothpaste next week. We'll see if that happens, but at least today, no explosions. Who's holding the camera? No one's actually holding the camera. It's my laptop clamped to something else in my kitchen. Actually, my dishwasher is like right behind all of the camera setup. And then I have a TV so I can see the screen a little bit bigger. Hello to everyone. I see a lot of, in the chats, I see a lot of people checking in. It's good to see everyone. Some of you guys are my students. Some of you are former students. Some of you guys may just be random people. Who knows? Maybe we'll get this to the point where we have some random people popping in. Okay, so now we're going to do pH stuff. I have a pH indicator strip here, and I'm actually going to zoom in a little bit more. Hopefully you guys will be able to see. There we go. I think I can still be in frame there. Yep. Cool. Okay. So before we do each thing, I'm going to test the pH. So water should just be right in the middle. And it matches about at a 7. Okay. Yeah. Seltzer water. That's what we're going to do next. Seltzer water seems to be about in that same range. Maybe a 6, a 5, or a 6, or a 7. It has gone flat. Sometimes when the bubbles are in there, you're going to get a little bit darker thing. But this should be acidic. Our seltzer water should be acidic. Okay? So I'm going to pour that in there. Remember, this is purple. Yeah. Not much of a change there. Our seltzer water was pretty close to our original color, which makes sense because the pH strip was about the same color as well. Next, we have a solution of baking soda. So baking soda is so it should be somewhere on that basic scale. And we can see that here. Color comparison wise, we're at about an 8 on the pH scale there. So slightly a higher pH than basic. So let's see what color that changes into. We get a really nice like turquoisey color out of that. Which is pretty cool. Kind of same color as my shirt. Okay. Next, I have lemon juice, and lemon juice has something called citric acid in it, and so citric acid is going to definitely be acidic. How acidic, we will have to see. It changes the pH strip like a pinkish color, so I would say we're pretty low on the pH scale there, maybe like a 2 or a 3. So we'll have to see what color that turns the juice, or the, yeah. Okay, so you can tell like a really vibrant, say fuchsia. Really like that color. These two colors side by side are pretty cool. Okay, next is just water. So our water should be about the same color. Shouldn't change much. If anything, it's just slightly diluted. So This is neutral. This is distilled water. So you can see, although that seltzer water didn't change much color, it is slightly pinker than the distilled water. So it's definitely not neutral, but maybe it's at like a 6 on the pH scale. Okay. Next, we have something called milk of magnesia, which is a natural base. Get some more pH paper out. Milk of magnesia is a base. So that one's got like a greenish color. I would say that's like maybe at a 9 or a 10 on the pH scale. Okay, so, and this is not clear. I know it's hard to see on the white background. I actually put that there because of the red and make it a little bit easier to see most of them. But milk of magnesia, you can tell, is not clear. But it doesn't have a colored pigment in it, so it should still be close to the correct color. Okay, so put that in, and we get like a maybe even more of a green than our baking soda. So this is more of like a bluish green. This is more of like a green. Okay. Next is vinegar. Vinegar, the active ingredient is a substance called acetic acid. So again, just by the name, we know it's an acid. Vinegar strip looks like that, which is probably going to be somewhere close to the baking soda, or not the baking soda, sorry, the lemon juice. Definitely down there in the maybe 1 to 2 range in terms of the pH. So we'll go ahead and do that. Vinegar. Oh yeah. Maybe even more red there. I would say vinegar is a little bit lower on the pH scale. And then finally, we have borax. So borax is a cleaning product. Many of you probably know what borax is because you use it to make slime now. That's the most common thing. But it's a cleaning product. You can add it to laundry detergent. You can use it to scrub things down. It's a really good disinfectant. And it's really slimy when it's in water. That's a key thing to know about bases, is that they feel slimy in water. And so if I stick my finger on that, it feels slippery. Okay. So we have borax. I'm going to give that a pH strip test. Need one more piece. Okay. Borax. It turns it like a greenish blue color. So that's probably a 9 or a 10 on the pH scale. So we'll add that in there. And I would say that's probably our most basic so far. There might even be some sort of secondary reaction happening there. That's a pretty gross, dirty water looking color. So those are our different substances with our indicator in it. Perfect amount. So we can probably like just color-wise rank them from acidic to basic. Remember, our distilled water is in the middle. I want to put things that are more acidic on this end. If you remember from our pH scale up here, I know it's a little bit out of frame, but seltzer water is probably the closest right there. And then I would say lemon juice. And then vinegar all the way on the end. Okay, so we got vinegar, lemon juice, seltzer water, all acidic. We have distilled water with our indicator. That's neutral. And then we need to work our way here. I think baking soda is a little bit less. I'm not exactly sure with these two. We'll go milk of magnesia, baking soda, but I'm not sure which of those two is more basic just based on the color. I think our milk of magnesia was a little bit more green on our pH strip. So I think this is a little bit less basic, a little bit more basic. And then finally, our borax at the end is our most basic. And we don't have quite a rainbow, but we have at least like a setup here of our different pHs. So that's a little bit of a lesson on the pH scale. It's a little bit of a lesson in how we can make acid-base indicators. So you can do this at home. And then a lot of these things are substances that you probably have laying around your house. So a little bit of kitchen chemistry for today. Just to wrap up, I will take a few questions if anyone has questions. Don't see any questions. So hope you guys have a great week, and we'll be back next week. Hopefully I will get us back outside and oh, one question. Daniel said, sorry if you said this, but why? Why does this work? That's a great question. It all has to do with the physical makeup of the molecule. So there's some sort of pigment that naturally occurs in cabbage juice, and I'm not sure what it's called, but it's a certain substance, and various substances just have natural colors. And so this one, the molecule changes in slightly different ways depending on going from one thing to another. And it's going to just absorb and reflect light in slightly different ways. And so probably some sort of adding those hydrogens or different concentrations of the hydrogen, because that is really what pH is. It's a concentration of hydrogens in the substance. It's just going to change that molecule in slightly different ways to change the color scale. Good question. You got to have a little bit more understanding of what pH is to know other than that. But it's like a concentration of loose hydrogens, and those all come from the water. So acids and bases are always solutions of water. Could this work with other vegetables? I don't know if there are any other vegetables. I will maybe try to comment below or put it in the description if I find some. There are definitely other substances that this works for. There are other naturally occurring substances that will change depending on where they are on the pH scale. But I'm not sure if any other veggies would do that. That's a great question. Cabbage is the only one that I've ever tried. I did this as a demonstration during my student teaching, but I haven't revisited it since then. So I'm not sure. I'll have to do more research and find out for you guys. Daniel found for us already. There's a pigment called anthocyanin that changes colors when it's mixed with an acid base. I feel like maybe carrots could possibly work like this too. I don't know. I'll have to do more research. I might just be spewing misinformation here. We'll have to see. Okay, so I think this is going to wrap up for the week. I don't want this video to be too long, but I hope you guys have a great week. And I look forward to seeing you next week. Maybe we will blow something up next time. We'll see. I know you guys really like the explosions. I'll see you guys. Bye.